Hello, so in today's video, in this A-level math series, we're going to go on to the next topic, which is the laws of indices. This is kind of a revision of the GCSE syllabus where we looked at laws of indices there. So yeah, I've just listed out 6 laws of indices that that you just need to learn essentially, or you need to understand for the syllabus. So I've just specified up here that A is greater than 0 and N and M are real values. So I've specified that A is greater than 0 just because, for example, if A was a negative number, so for example, -2, if you do -2 to the power of a half, for example, well, that's just the square root of -2. And this is not a real number. So this is not a real value. So yeah, I've just specified that A is greater than 0 just to avoid this, essentially these imaginary numbers. So yeah, and then N and M can be real numbers in these examples here. So we just look at the first example. So we've got a to the power of n times by a to the power of m, and that's the same as a to the power of n plus m. So this is the rule where you add the indices, add the powers together. And just an example here then. So 2 to the 3 times 2 to the 4 is basically 2 times by itself 7 times, which is 2 to the power 3 plus 4, which is 2 to the power 7. So that's just an example illustrating this law there. So the next law, so a to the n is when a to the n is divided by a to the m, we get a to the n minus m. And again, here's just another example down here to illustrate that. So 2 to the power 3 divided by 2 to the power 4. What we can see here is that the 2's cancel out there and there, there and there, and there and there. So we're just left with 1 over 2, and that's exactly the same as 2 to the power 3 take away 4, which is the same as 2 to the power of 1. We'll come on to this down here in this number 4 law. The next law, number 3, so a to the n all to the power of m is going to be a to the power of n times by m. And again, one way which we can illustrate that as an example is by looking at this example here. So 2 to the 3 all to the power of 4 is just 2 to the 3 multiplied by itself in 4 iterations here. So we get 2 to the 12 by adding the powers, and that's just the same as 2 to the power 3 times by 4. So yeah, that's our third rule. So the next rule here, kind of relating to this point down, this point up here. So a to the power of negative n is just the same as 1 over a to the n. So just to illustrate this, so yeah, 2 squared times by 2 to the minus 2. Well, when you add the powers, you get 0. So this is 2 to the power of 0. Obviously, that's the number 1. So one rule actually I really forgot is this rule number 7, that anything to the power of 0 is 1. Well, when a is a number bigger than 0, this is true. So yeah, we've got the number 1 here, but that's obviously just the same as 2 squared times by 1 over 2 squared, just because the 2 squared there and the 2 squared there cancel out. So what I'm trying to illustrate here is that this number there is the same as that number there. So yeah, that's the 4th law in this list. The next law is this one. So a to the n over m is the same as the mth root of a all to the power of n. And actually something that I forgot with this one here is that m cannot be equal to 0 in this case, just because if you divide a number by 0, you get an undefined result. So this power would be undefined in this case. So yeah, so in this case, again, we've got yeah, just an example here to illustrate that. So 2 to the power 3 over 2 times by 2 to the half. Well, by using the addition law, you add the powers to get 2 to the 2, because a half plus 3 over 2 is just 2. So we get 2 to the 2 there. But that's just the same as root 2 all cubed times by root 2. So root 2 times root 2 times root 2 times root 2 is 4, which is 2 squared. So basically what I'm trying to say here is that this number corresponds to this number, and this number here corresponds to this number here. So that's our 5th law. And our next law, then again, we just need to make a point here that m cannot be equal to 0. So our next law is a to the negative n over m is 1 over the mth root of a to the power of n. And again, just to illustrate this example, 2 to the minus 3 over 2 times by 2 to the 3 over 2 is again just 2 to the 0, just because you add the powers. So minus 3 over 2 plus 3 over 2 is just 0. That's the number 1. 2 to the 0 is just the number 1. And again, we can just correspond these two numbers here. So that number with that number, and this number with this number. So that's just an example to illustrate how this sixth law here works. So yeah, those are the 6 laws, and you've got this obviously the 7th one here, a to the 0 equals the number 1. And I mean that can be true as well for negative numbers, as long as a does not equal 0, then that's fine up there. If a was equal to 0, you get 0 to the power 0, and that's undefined. There's no definition for that value essentially. So yeah, those are the laws of indices, just the same laws that you learn in your GCSE syllabus. So it's just a case of learning and remembering how to use those laws. So yeah, that's the end of today's video.